This is a problem-solving video from our utility unit. And I got a question about this problem in email, and I wanted to make a quick video to take a look at it, show you guys a little bit about how to deal with it. So you see we have a chart here of marginal utilities, and I want to point out here that that is what we're looking at here. We have marginal utilities, not total utilities. That tells us that we're going to need to pay attention to how each good's utility contributes, not how a particular bundle of this many goods is going to contribute. So for example, the first unit of product X we get is worth 32 utils. The second unit is worth 28. So if we consume 2 units of X, we get 32 plus 28, we get 60 utils. This is the contribution for each individual util. So our job is to take account of the fact that the prices are $4 and $2 respectively for products X and Y. We have $20 worth of income, and we want to find the utility maximizing combination of X and Y. Our output is going to be a total utility number. So what we need to do is we could either calculate total utility at each bundle using the shopping cart method to determine the best purchase, which is what this video is going to focus on, or we could calculate the utility of feasible bundles directly. We're going to use the shopping cart method here just because it's a great method. It's a thing that you can remember to solve one of these utility problems. Buckle up, this might be a long one. Okay, so we have our information here, but what we want to do is calculate not just our marginal utility, but we need our marginal utility per dollar. That's going to be one of the key pieces of information to use what we call the shopping cart method. So I've added a little bit of space so that we can include our marginal utility per dollar. The price of product X is $4. So if we get 32 utils from the first unit, 32 divided by 4 should give us 8. 28 utils from the second unit, 28 divided by 4 gives us 7. 24 divided by 4 gives us 6. 20 divided by 4 gives us 5. 16 divided by 4 gives us 4. So we have that column ready to go. And this is going to be useful for us. Then we're going to do the same thing for product Y, which has a price of $2. So go ahead and pause the video and fill in that MU over P column. MU over P, that's marginal utility, that's your MU, over dollars spent, that's the price, MU per P for quantity Y. Pause the video, and we'll come back in just a moment. All right, I'm assuming you have paused the video and filled in this column, not too terrible. It should look a little bit like this: 12, 10, 8, 6, and 4. All right, now our shopping cart method is we're going to buy whatever item gives us the most utility per dollar spent. Keep going until we run out of money. No big deal. So when we run out of money, we're done. We have our optimal bundle. So let's take a look at our first purchase, and I'm just going to shrink the marginal utility columns out of here so that we can pay close attention to only what we're focused on. So for our first purchase, take a look. Which item has the highest marginal utility per dollar spent? Let's see. Everything with X starts off at 8, and we have diminishing marginal utility, so all those numbers go down. And then the first unit of Y is worth 12. So we're going to purchase 1 unit of Y. Okay, there we go. We're going to purchase 1 unit of Y. We're going to spend $2 of our $20 budget. That means in our pocket, we have $18. In our shopping cart, we have 1 unit of Y. All right, so for our second purchase, we already have 1 unit of Y. So now we need to compare our first unit of x, which is 8, to our second unit of y, which is 2. Okay, cool. We're going to have to buy a second unit of y. Let's go with that. And so we're going to buy a second unit of y. We spend $2. We have $16, and we have 2 y's in our shopping cart. We have $16. Now we're going to have to make our third purchase. We've already bought 2 units of y. So now we have, oh, this is interesting. First unit of x is 8. Second unit of x, third unit of y is 8. Huh. It doesn't matter what we do here. They're both going to give us the same number. And since we have $16, we can afford to buy one of each of them. So why don't we just buy both? So third and fourth purchases, 1x and 1y. We're going to spend $6. That's $4 on the x, $2 on the y. We're left with $10, 1x, and 3y. Okay, let's keep moving. We've already bought 1x and 3y. So what's our highest remaining number? It's going to be that 7 from the x column. So our second unit of x is going to give us 7 marginal utility per dollar, whereas that fourth unit of y is only going to give us 6. So for our fifth purchase, we're going to buy another x. We spend $4. That leaves us with $6. Now we have 2 x's and 3 y's in our shopping cart. Sixth purchase. We have $6. Okay. We could buy either because we've spent all but $6. We have 2 x's, 3 y's, and then our fourth unit of y gives us 6 utils per dollar. Our third unit of x gives us 6 units per util. So, utils per dollar, rather. So, we're going to buy 1x and 1y. That's going to use all the rest of our money here. That's going to give us no money left. So cool. We have consumed all that we can. We have 3 units of x and we have 4 units of y. We now know what the optimal consumption bundle is. But that's not what we're after. We need to know what the total utility is. While we're here, by the way, give me just a moment. I just want to highlight something. We bought 3 x's and 4 y's. What's the marginal utility per dollar spent for each of them? Well, our fourth y gives us 6 marginal utility per dollar spent. Our third x gives us, interesting. 6 marginal utility per dollar spent. At the optimal bundle, marginal utility per dollar spent is equal for both goods. So our fourth y is worth the same as our third x. Okay, folks, we're in the home stretch here. We know what our bundle is. Now that we know what our bundle is, we need to figure out what our total utility from this bundle is. So our total utility from x, we're going to get 1, 2, 3 x's. So we're going to add up 32 plus 28 plus 24. If I've done the math correctly, that's going to give us 84. But that's not our whole bundle. We also need to add up our utility from our 4 y's. We have 4 y's. So we're going to need to add up the utility we get from each of those. 24 from the first one, 20 from the second one, 16 from the third one, 12 from the fourth one. So 24 plus 20 plus 16 plus 12, that's going to be 72. And if we want to add all of this together, 84 plus 72, that's going to give us our total utility, which is going to be 156. All right, and that's our answer. So, just to show you what this looks like, we have 3 x's and 4 y's. We found that that was the optimal bundle using our shopping cart method. Then, our answer is going to be our total utility. We just calculated that as 156.